Suppose we don't need the recursive OBS going on there, huh? Oops. All right. Good morning. Welcome, happy Saturday. Let's see, I don't have any of this stuff set up. All right, here we go. So welcome, first of all, thanks for watching. For anybody that might be new, my name is Tim. I go by Foamy Guy on GitHub and Discord, and I typically stream about this time each week. I'm a few minutes late this week, but around 10 a.m. Central Time on Saturdays. I usually stream working on some CircuitPython related stuff. You are new and you don't know what CircuitPython is, you can learn more at the main website for the project right here, circuitpython.org. This is basically a version of Python that runs on tiny computers called microcontrollers. When you choose to use CircuitPython with these devices, which is just only one way that you can program them, there are a bunch of others. But if you do choose to use CircuitPython, typically the way it works, you plug this thing into your computer with a USB cable. It shows up like a thumb drive, just an external storage drive. On that drive, there's a little code.py Python code file. You can open that in whatever text editor you want and just edit the code inside of there. And when you save it, the microcontroller, the computer that's in these little chips here will actually notice that you saved the file, and it will reset itself and it will reread the latest version and it will execute all the code that's inside of there. So you can just very quickly make changes to your program. And most typically these microcontrollers, come with other peripherals, or I shouldn't say maybe come with, but they're intended to be used with other peripherals. A microcontroller by itself is just kind of a generic way to turn stuff on and off and take readings from sensors and do all kinds of stuff like that. Usually you will either have some stuff built into the device, like this one is kind of made to be a little macro pad, or this one's made to be kind of a little sort of a tablet type thing, little touchscreen device there. But there are some that are just general like this with loads of pins that you can hook up whatever you want to, whether it's buttons or lights or anything else. How's it going, C. Grover? Good morning. Let's see if I can fix my... Oh, right. That's the other one. Let me see if I can fix this one. There we go. Yeah, sorry. Get distracted by the Discord mostly. Not the chats in the Discord. In this case, it was the OBS Discord thing. So where was that? So usually these things, they'll either have some stuff built in, like the little tablet one or the macro pad, or lots of pins like this where you can hook up whatever you want, whether it's buttons or lights or whatever. In particular today, how's it going, John J? Let's see, Yanaj. think you told me once, and it took me a second to remember, but I know it was not John J. Yanaj, I think, or Yanaj, something like that. My apologies for getting that wrong. PyPortal is what I am working on today. So this little tablet one, we're going to be diving into some DisplayIO stuff. And it's, let me start with, well, let me turn the camera on and then you can see, you'll be able to see what we're working with here, or what we're working towards, maybe is a better way to say it. Yano, that's what it was. Yano. 225. There's the blurry version. Let's see if we can focus. Let's see here. There we go. It's just not super easy to see, truthfully. Like that. I feel like we usually get a better, I guess it's just because of the darkness or the particular pattern. Maybe it will be better to just use no light. Yeah, that's looking a lot better, actually. Okay, so let's just go with that. Okay, so new project idea for me is a spirit board, or commonly known as a Ouija board. Let's see what comes up. Yeah, so I would assume that Ouija is probably the most common sort of, known one of these in at least the culture that I'm in. But I do think they have a longer history and all kinds of other variations. Obviously, there's lots of different ones we can see, even just on the first page of results here. But I figured this would be a good project for Halloween upcoming, and it will give me a chance to do a few things with DisplayIO that are not necessarily super easy to do today. So I do have, as you can see here, which let me pop this to another window, I do have a board, a background here. I found actually found a public domain picture of wood, and I kind of rotated it and scaled it down and got it into this PyPortal. This is a PyPortal Titano, although I do at some point intend to go back and make one that will fit the smaller PyPortal as well, the regular PyPortal, I should say, not the small one. Although I think maybe they have the same pixels on those two, although I'm not sure. I don't have the small one. I have the regular one and the Titano one. So everything here is just an image. This is an on-disk bitmap, but the bits that I want to work on today specifically are the little thing that moves around, which I have come to understand is called a planchette. I don't know if I'm pronouncing that correctly. Maybe perhaps planquette. But this thing is kind of interesting from a CircuitPython DisplayIO perspective. Probably will use another on-disk bitmap or maybe a image load bitmap. We need to have transparency because we need the cutout, the little circle, so that we can see through whatever letter it's highlighting. And what I would like to do is be able to render this thing and move it with an anchor point and an anchor position. So if you have ever used display text, one of the ways that that's a very specific place that I linked to. Interesting. Okay. One of the ways that you can use the labels inside of display text is with anchor point and anchor position. And this is just a way of placing the text within the screen. It allows you to do things like anchor the right side of the text against the right side of the screen without having to do as much manual math yourself, like figure out how many pixels are in the display and how many pixels are in the label and subtract them and do all of that stuff. Ultimately, that's what it's doing under the hood. But this is a more convenient way to do it in code, at least in my opinion. And the way it relates to here is it'd be really, really nice because, like, ultimately this is going to be a tile grid, right? This is going to be a rectangle. You know, these are angled. Maybe we should use this one. That's a better example because it's vertical. So we're going to have a tile grid with this thing in it. there's going to be a transparent section right there. And when we're moving this around, by default, it's a tile grid. So by default, it moves around with its sort of 0, 0, its top left corner up here, which is fine, but it sure would be nice if we could actually move relative to the little window, right? If we could say, this is the anchor point, and, I want to move it to the coordinates for the G, that would be pretty convenient for us to not have to worry about the difference between the window here and the top left pixel there. So I would like to take this concept from label, get it to work with a tile grid so that we can move this around based on that anchor point, which I will use as the window for my thing. But obviously once this exists, then you can make your anchor point whatever you want, right? So if you have a different picture that makes sense to anchor in a different location, you'll totally be able to do that. And before I dive straight into that bit of it, that's what I'm going to start with on the coding side, but I will just follow up a bit on the rest of the project. The rest of the sort of vision for the project is I intend to use the Pi portals, and maybe we'll go back and do one for the Feather, any Feather that has Wi-Fi, so like Feather S3, Feather S2, with like obviously with a display added on, so like a Featherwing TFT Featherwing display added on for those. And the way that I ultimately want this to work is you, the user, whoever's doing this project, you will actually be able to control the message that comes out through Adafruit.io. So hopefully we can get this set up where there's a feed in Adafruit.io. The code in here is going to check that feed for the latest string value that's in it. And that string value, that's going to be the one that the planchette moves around and actually displays. So if you want to use this board with your friend or family member or whatever, you can kind of set it up where you're like asking it a specific question and you've kind of preloaded the answer that will be the most fun for your situation. Yeah, so that's the idea. And then that's the specific thing I want to do right now. And I think the first way that I'm going to approach it, so like I was actually a moment, well, not really a moment ago, but the other day when I was thinking about this more, I was thinking about diving into the core and just starting to modify tile grid to have anchor point and anchor position. I'm going to go a different route first, though, actually. And see if we can just, because I think we probably can just do this at the Python level, which is basically how it's done for the labels anyway. So I'm going to make a new file here. We're going to call this a anchored tile grid, which is going to have a class anchored tile grid. Why, yes, I do want to import that and extend it. Thank you very much, PyCharm Code Writing Assistant. That was very kind of you. So the constructor is not going to be any different. I don't think we want really any of this. Honestly, Quargs, I don't even think we need that really. Well, do we? Yeah, I guess we do, kind of. Tile grid, does it take arguments too, or just Quargs? So tile grid, I think you have to pass it bitmap equals, right? DisplayIO docs, bitmap equals, and then pixel shader equals as well, I think, right? Tile grid. Tile grid? Yeah, I think all of those are named. Oh, no. The bitmap is not, actually. It can be. Okay. It's interesting that pixel shader is keyword argument, but bitmap is not. I guess, is there any case where you don't need to pass the pixel shader too? I think there's not, off the top of my head. Okay, so we could do args. I think instead I'm just going to say bitmap. I'm just going to give it the real name here, bitmap. Because we know what it is, right? We know it's the first argument of parent, which is tile grid, which is bitmap. So we super that. Okay, so now we have a self instance of tile grid. And then really the only other thing we're going to do here is go self. Actually, do we want properties or just straight values? Let's look at label. But it's not going to be in here because it comes from base. Okay, those are properties in this one, so I think we should probably just stick with that. Yeah, technically this allows passing them into the constructor. I mean, can you pass X and Y to tile grid? Yeah. Okay, so we're gonna say 0 if X not in quargs, else use quargs X, and then we're gonna do the same thing for Y. So if they don't pass X and Y in, then use 0 for any that doesn't get passed in. If it does get passed in, then use the value that was passed in. But we are, for now at least, just going to anchor point to 0. User will have to change that after initialization. We could go back and add that later, though, if we want, like label has. I'd like to just get it to work first, and then maybe. And so here, this is easy. Just return that. I don't think we care about baseline. Do anchor point 1 equals baseline. I don't really know what that's doing. Nothing, I guess, to do with base alignment. I'm also not sure what a negative will do for that. Okay, I don't think we have base alignment. That's like a label thing that we're not going to have for tile grid, I think. So instead we basically are just doing this and then doing the anchored position. Well, we do need this part though. pretty close, kinda, sorta. Maybe we can take the comment also. All right, so that one's easy. And then this one we get a bit more. So new position. So only do it if we have both an anchor point and an anchor position. Because if we did not have one or the other, then it would be kind of ambiguous what to do. So the main thing is new position minus, so this is saying, I'm going to get rid of scale because scale, we don't have scale at the tile grid level, right? That's a group concept. Label is a group, or has a group, one or the other, I don't remember. And therefore it has scale. I think it is a group because you can pass scale to the constructor, which is actually just going to the group constructor. But we don't have that. We're a tile grid, and tile grids don't scale like that. You would have to put it in a group and then scale the group, which you could do. It may or may not mess up the anchor point, I'm not sure. But for now, I'm planning on no scale. We'll worry about that later if we need to. Okay, so new position minus, so bounding box 0, I think is, so in label, bounding box is, I'm pretty sure it's like XY width height, yeah. So bounding box 0 would be X, which is on a tile grid, just X. I mean, on a label, I think it's also X, but bounding box 2 would be Y. We're gonna not do the baseline thing again, so let's get rid of all of that and just bring this back. Bounding box 1, so that's Y. Why did we use Y up here, though? Actually, that doesn't make sense. Because anchor point 0 is the X anchor point. It should never really be doing anything with Y. Bounding box 2. Bounding box 2, that said. Which should be width, actually. Which makes a lot more sense. I think I saw 2 and I didn't zero base it. So I saw 2 and I thought it meant the second thing in the list. But it actually means the item at index 2, which is the third thing in the list, which is width. So width is a trickier one. On tile grids, you need to get the tile width and multiply it by the width, because the width property is returned in the units of tiles, and then the tile width gives you the width in pixels of each tile. Okay. All right, so bounding box 1, that is the actual second item in the list, the item at index 1, which is the actual Y, which makes sense because we're dealing with Y now. Anchor point, bounding box, so 3, that is the fourth item in the list, which is height. And again, we need to do basically the same thing for height, which is multiply the tile height times the height in tiles, which is self.height. Okay, I need a thing to test with, which I don't even have yet, so I'm going to make a super duper basic one here. How big do we want it to be? I think, let me open... How big are these things? I think I want my circle to be a circle, not an oval. Hey, whoa. What? Is that making a perfect circle, or is it... It's like an oval, isn't it? Okay, that's probably about the circle size we want. And that is 76 by 76. So let's say then the entire planchette is going to be a little bit wider than that and a lot of bit, maybe like 3 times as tall. Maybe not 3 times as tall. So we don't want it to necessarily cover up too much. I'm actually aiming for fairly small overall. Let's try like 100 width and 200 height, and or like 100 width and 140 height, and see what that looks like. No, 100 width. I'm just going to fill it with green for transparency. And this is going to be kind of bad. Maybe I can do like, maybe I can make it a little better by... Okay, well first... Oh, that was that... Okay, the size is not square, which is weird. So size, I was wrong. That was the XY that I was looking at for 76, which means this is way bigger than we need, honestly. So if the size is 42 by 42, we really want more like a width of maybe 70 and a height of maybe 110 or 120 or something. I mean, I guess we can just go ahead and do that. .42 by 42. Can you center a selection? Is that a thing that happens? Yeah, I don't think so. Okay, well, we can center it because we know the width of this is 70. Yeah, wouldn't be nice if we had anchor positioning for selections inside of... whoops. we had anchor positioning inside of here, it would be convenient, but we'll just go 42 minus 70 is 30, no, 28, I guess. You have that 14. Okay, we want this towards the top, so maybe might not be wide enough. Okay. I'm gonna make an empty one, and I'm just gonna fill this as like a thing to use later. It's not really gonna be not really gonna be part of the final thing. $70 and $70. We made these as like 35. Could we? I am gonna just use kind of a random color, I think. I don't think we will end up on this color in the end, but kind of want just something. We'll make another new one of these. Then this. And move my selection over. And then pencil or let's do one for now. I should have maybe done an odd width, would have been a better choice. So 35, 34, and 35. Why is that not doing anything? Sorry, finally able to pull up the stream. Was wrapping up some things after a tough morning. What's the project? Yeah, no worries. I am working on a spirit board, which is like better known. So there's my version of it, better or best known, at least in my culture. Like Ouija board is the name of a thing you can buy. I think from Hasbro or somebody. But I'm working on this with DisplayIO, and I want to be able to control it through Adafruit.io. So you'll be able to kind of go in your Adafruit.io account, add a string into there, and then like if you're playing this Ouija board with your friend or your family or whatever, you can kind of stage the answer, right? So you're going to sit down with them and be like, hey, do you want to play this thing? But you're actually going to have secretly loaded in the answer, so you can set up like whatever would be most fun or interesting or funny for you and your friend or whoever you're playing with. Is kind of the idea. And then it will hit Adafruit.io server and get the string and then fly this little thing around and show you whatever letters make up the message. And so right now, specifically, I'm working on just a test planchette is the thing that moves around. So I'm working on that in order to start testing with. I think it's because we have a selection. Yeah, there we go. So I think we go like this, maybe? I should have probably 88. Okay, that's pretty good for a few minutes here. That's good enough for us to test with. Well, that's a little big, isn't it? Okay, so we'll have to move that down some. Or the other option is we'd have to try and like curve this some, which really is the solution we want to probably end on. This actually might make it fairly easy to do what I want. It's kind of, it's a bit curvy at the top. Oh. Doesn't like to be selected outside there. That's a bummer. All right, well, let's not get too into the artwork. This is not necessarily meant to work on the artwork. I can just move it for now. So take this thing. I do want to put it in the center. I do want to make sure it's centered. Okay, seems like, oh, that's not actually doing anything. Fair enough. I don't know why this doesn't work always. I don't know how to get this thing to work. Yes, this thing, I would like to move it. How do I do that? No, doesn't say. If I paste this, then I can do it. No. I don't know how this thing works, but it's not really working for me. Somehow you can use that to move stuff relative to the, I mean, yeah, relative to the image is what we want. So one problem would be this layer is the full size of the image, I guess. So that's not going to work, but this one isn't, and it also didn't work, so. Looks like we are centered already though, so we can just go to move, click very carefully. Oh, that's annoying. Okay, let's just get rid of this one. There we go. Just work with it like this. So I want to select that, and then I do want to shrink it some because we got a little bit of extra there. We don't really need it to be that big. Shrink by maybe, honestly, maybe even 2. By 2. 2 might have been too much. Let's shrink by 1 instead. Yeah. And then I want to go to layer 1 and actually we can hide that. And then layer 1 I want to delete, which is going to cut a hole out. Okay. And then we want to just take this whole thing to indexed. Call that V0. Planning on making a better one at some point. I will do BMP. We have PNG support for image load, but I think I should be able to just use onDisk bitmap for this. We do want to make sure green is number 1. Well, 0 actually, index 0. It's not, so let's do that. Save again. I don't know if I opened that actually. I mean, I guess I don't really need it in PyCharm. Did I close the wrong one? Or I just never closed this? Okay. Okay, so we have the background already. Let's try to use that anchored tile grid and see if this even works. Well, maybe we should just use regular tile grid first and then... Maybe we'll do ODB. Make transparent 0 to make it so the green doesn't show. And then we can just add that to main group and see if it actually renders. I think this has auto reload turned off. Okay, perfect. Awesome. Okay, that's working fine. So we want to now, let's see if I change this to anchored tile grid from anchored. This thing, I will say, it's gotten better at finding stuff inside lib. It didn't used to be able to really find stuff inside a lib and auto-complete it like that, and now it does. Just pretty sweet. Little practical joke. Yeah, basically. Yep. That's the idea. I mean, you could probably... I could probably build a list of random responses too and have it like actually give you random responses if you want that. But the tie-in to I/O is definitely the core of my ideas, being able to secretly control it. Okay, so yeah, let's just, does that even render at all or completely break everything? Yes, it does, which is pretty sweet. All right, very good. So can we anchor position it by something? So if I were to go and say, I would like to use as an anchor point, let's say 35, 65, or 66. Tile grid dot anchor point equals 35, 66, and then anchored position. Let's just go with the middle of the display and see if that works. So display.width over 2, display.height over 2. So this should line up the window with the center of the display if it works. No dice. Okay. Let's make sure we got inside of here. Could answer randomly when you don't supply a specific answer. Yeah. Or it will depend on how we integrate I/O. It could be like my initial thought was that it would take the most recent one in the feed. So it wouldn't necessarily know if you put the most recent one recently. Maybe you can get a timestamp too. I'm not sure. But you could I could definitely set it up to where, like, you know, if you give it the word random or some like hard-coded value that means random, then it could go back to its list. So I do not understand what happened here. My understanding is the only thing I changed from the last time I ran this was this print statement right here, which should not affect the position of the thing at all. So either it... Yeah, I guess maybe I just didn't run it again last time. I didn't rerun it or something. I don't know, but it is moving it now. But the problem is actually that the top left is where that's at. And the problem with this is we don't use pixels for this. This needs to be scaled down to between 0 and 1. This actually needs to be floats. Well, okay, so we know the width. We actually want the middle, so we can actually just say 0.5 there. And then the top, I had 66 out of 110, so that's what? We could use Python for that. We don't need a calculator. I mean, Python is a calculator. You could even use the CircuitPython device. 66 over 110, isn't that right? 1.6, okay, 0.6, I mean. 0.6. Yeah, so we're saying we want to anchor it at the middle horizontally and then the 60% way vertically. So 60% down the rectangle. Still does not actually work though, but I'm just gonna run it again because like last time when we ran it again, it did something different. So okay, doesn't seem to make a difference. All right, let's get back in here. Let's turn that back on. Let's print the new position. Because it should be none the first time, or 0, 0 the first time. And then it's 240 by 160 the next time. Let's print the anchor point and make sure that it's set to what we think it is. We could be using the property here instead of the private variable. All right, so both times that was already set. Hmm. So we said new position 0. So 240. So we're going to set the X to 240 minus the X position of our object. In this case, it's times the scale, but we don't have scale again, so we're just going to say that that's 1. So 240 minus... I don't really understand that part, actually. I mean, the scaling makes a little bit of sense, but why would we be subtracting the X position? That doesn't really make much sense. Maybe that's not the X... No, I don't know why that's happening. All right, I do have to run to the restroom also, so I'll be back in a minute. Does setting the property instead of the private variable trigger a redraw? Yes, that's the goal at least. So in the case of anchor point, when you set it, it will explicitly also set the anchor position using the property setter here, although it does set it to the private variable. And then in the setter for that anchored position is where it actually goes and updates the X and Y. Okay, BRB. Okay. Had an idea. I wonder if these parentheses are messing something up. I don't know why that would not be the case for the label, though. I also still don't know why we would be subtracting the X minus the scale. Okay. So I was thinking like maybe this was like confusing it and actually doing 20 minus 20 is 0 and then 240 minus 0 is 240, but that's not the case. So the real value that we're expecting for x should be about 35-ish pixels less than 240. So it should be like 205-ish. But instead we're getting actually 240. So when in doubt, print it out. Just print every variable here, try to figure out which one of them's messing things up. I don't really follow why we need that. I wonder if we don't need that, maybe. But the thing is, like, even if we didn't need that, it shouldn't lead to this outcome. So this is basically the scaled width. It's not really the scaled width, but I'm going to call it that because I can't think of a better name. It's like the scaled X position, kind of, based on the anchor point and the width. Say scaled width position. So let's focus on the second time this gets called, because the first time it's at 0, 0. We don't care about that so much. Okay, maybe we do care about that so much, because actually so it's working correctly the first time. Yeah, here's totally what's happening. It's actually working correctly the first time. When it places it at when it anchor positions it at 0, 0, it's actually correctly putting the x to -35, which is half the width, which is what we told it. So that actually makes sense. And then when we do it the next time, it's subtracting that 35. So it is down to this thing that I don't know why it's here. So I guess we get rid of it. But I am still left perplexed. Like, why is it there in the label one? Because, like, thinking logically about it, the new position is not based on anything at all related to the old position. The new position is based only on the only inputs to figuring out the new position are the anchor point, the width of the thing, which in the label's case is this here, and you know, in the case of the label, the scale is an input, but we don't have the scale over here. So the anchor point, the width of the thing, and then the anchor position. Those are the only three inputs. Like the anchor position that the user passed in order to set it, right? Those are the only three inputs. It shouldn't, like, where it ends up should not depend at all on where it was before. It should only depend on those three inputs. So I don't understand why this code is like this and why it works with label. But we're not working on label for now, so we'll leave that mystery alone. Ah, there we go. All right. Okay, that's totally what we want. I guess I'm just gonna delete this. That feels wanton, but we don't need any of this anymore. Wait, was it correct? 205-ish? Oh, but my calculation is wrong now. UX, we took this out. And now I took out all the prints. Yeah, 205. Okay, awesome. So now we can place the planchette based on like anchored to wherever we want, which in our case we want it anchored to the window. Because what I'm going to do is make a big dictionary of like, you know, the letter A is at these positions, right? Whatever X pixel, whatever Y pixel. And I want to be able to just put that planchette there without worrying about the offset of its width and height, and instead just set its anchor point and once and forget about that math, which looks like we should be able to do now. So if we wanted to test this theory out, let's say we wanted to show a B. B's pretty much at about 63, 115. So instead of the center here, we could say 63, 115. We should hopefully get a planchette that's window that's pretty well centered on that B. Yeah, look at that. Nice. Okay. And then what we'll basically end up having is a big list of these things. So we're going to have like locations. Do we have string in CircuitPython? No. So A is about 42, 145. Okay, so this part's going to be a little bit repetitive, but it's got to be done. B we already figured out at 63, 115. It's just making up numbers. Nice. I mean, it's got the right idea, I guess, but C is at about 96. We'll call it just 96, 96, maybe. Maybe we do need to go down. Maybe we'll call it 97, 97. All right, so let's stop there for a minute, and let's say, so now like message could be ABC. And we could even do this in here. We could put a time.sleep of maybe one second per. I don't know, we'll keep it kind of slow for now. Maybe let's do half a second. And then we could say like, yeah, not yet, I don't. But that's another thing that we'll eventually want to make as well, yeah. The slide function, by the way, yeah, for anybody who doesn't see the YouTube chat. Gordy G, I don't remember if I said hey to you, Gordy G. How's it going, my friend? Thanks for tuning in. First of all, it's good to see you. And yeah, slide function you asked about there in the YouTube. So, and that would be like to not just make the planchette blink from one spot to another, like teleport, but instead to like shift itself over. I do not have that yet, but that is another thing I'll be making here for this project. I don't know if we'll get to it today. Possibly. Got about 50 minutes left. I do have to stop pretty much on time today. Going to an art fair. Doing okay. Nice to hear. Nice to hear. All right, so we can say tile grid, anchor position. We want to go to, so let's make an index of 0. So we want to go anchored position is going to be locations. Locations message index. So the current index, we start on 0. We want to get the character from the message at that index, and then that character, we want to find it in this dictionary, and the value within the dictionary will be the location where we want to end up. Okay, so we do that, and then we go index plus equals 1. We could do this in one line with a modulus. Index plus 1, but modulus the length of locations, the length of message. Again, with that, making stuff up, you got to be careful with that part of it, I will say. The code completion is good, but it does sometimes... Which, I mean, in this case, it makes sense. And in this case, they happen to both be 3, so it would have worked, which is... All right, so it should move to the first one. It should wait for half a second. It should move to the next one. It should wait. It should move to the next one. It should wait. It should wrap back around and move to the first one. So this should just go... It is not going to slide, but it should just blink between A, B, and C. Nice. Yeah, perfect. Okay. Slide. Let's do work on the slide, actually. Instead of... That'll be more interesting, I think, than just going through and getting these things, right? That's probably not very compelling television or streaming. Sliding. So basically, we need to just get the points that are on the line between the place where we are now and the place where we want to go, and we want to move to each one of those points, or maybe we could skip some if we wanted to not take as long, or if we wanted to take bigger steps, so to speak. So the first thing we need to do is get the points along a line, which I don't know how to do off the top of my head, but I'm pretty sure geometry has a way. Python get points along a line. I'm going to get equally spaced points along a line in Shapely. We're not using Shapely. No NumPy, none of this. We don't want any of this. Hopefully. At least we can get by without any of this. Nope, Shapely. I don't want Shapely. Distance, length, interpolate. I can imagine GPS coordinates representing a location on a sphere-ish thing like Earth. Probably much more difficult, but I don't care about that. We're on a plane. We're pixels only. 2D plane. We're not quite in meters, but we could pretend to be in meters if it helps. We're in pixels, really. All right, maybe we should try without Python. See if we can just get the math. All right, start point XO, YO, end point X1, Y1. We need to find a point XT, YT at a distance of DT from the start point towards the end point. I can imagine how to brute force it, but you probably don't want to do it that way. Yeah. Yeah. I imagine, yeah, we could always just like kind of go up by 1 every so often. I mean, I suspect like if we find the slope of the line, the slope is just rise over run, which means the amount we move up over divided by the amount we move right. So if we found the slope, or really if we found the rise and the run, the two parts of the slope, then we could just start on the first one and add the rise, add the run, and that will get you like 1 unit further down the line, and then you could keep doing that, and you should eventually end at the end. However, we will have the problem of like rounding would make us deviate a little bit, so we do want to somehow hopefully not have that problem. So the distance between start and end point is given as this. So we actually have a nice easy way to calculate this, which is cool. Let the ratio of the distances dt is the distance. Okay, so t is the ratio of the distances. So we want to find... Okay, so what the way this one's working is it wants to find a point that is a distance away from the starting point and is also along that line, the full line, okay? So in our case, dt, we're going to say it's like maybe 1 pixel or a couple of pixels or whatever, a short distance. Something that will make the slide look convincing but not too slow. Okay, so then we're taking that smaller one divided by the full distance of the line to get that into a ratio. Then the point now is all this stuff. When 0 is less than t and t is less than 1, the point is on the line. When t is less than 0, the point is outside the line near x0, y0. When t is greater than 1, the point is outside. So basically, we would kind of like just, for the slide, we would basically just keep repeating this until our t satisfies one of these two conditions, which means we would have made it outside the line. I mean, I feel like we could always move in one direction, couldn't we? Couldn't we just always move one way, and then we would only need to check one of these? But I'm not sure. Okay, so let's try some of this. Def slide. I'm just gonna take the object for now, I think. I'm just gonna call it TG. Are you sure ghosts and spirits will take a direct line to the next letter? The remover more random, hesitating and doing it curves and stuff. I mean, potentially we could add some jitter. We could do some different stuff with it. To start with, I am just gonna do a straight line because that's easiest, and I tend to aim for whatever is the easiest thing first. But we totally could play with it a bit further beyond that. Curves, I don't know if we're going to get into curves because I suspect the math is a lot further over my head. But if I could find a place with the math that's easy to interpret and convert to Python, then I would consider doing curves. But we could do something like, send it, out a little bit and then back to where it's supposed to be. We could kind of throw it off the trail instead of take a completely direct line if we wanted. Once we have this slide function, then we could go and play around with how we use it a little bit. Instead of just sliding all the way from one spot to another, we could slide, to the first point, and we could jitter the first point outside of the line a little bit. We could shift it off the line. So, maybe it goes down a bit, and then the next time it goes up a bit, and then goes up a bit again, and then it kind of recenters itself or whatever. We could eventually do something like that. I don't know for sure if it will make it into my version of the project. It will depend on how quickly I get the base functionality working, because I kind of consider that like an embellishment, basically. But it would be cool. It would definitely make it a lot more like the real thing, for sure, which does tend to curve around based on the people holding it. Okay, so we're going to slide this tile grid to this position. So the position is going to be a tuple of XY coordinates. The tile grid is going to be actually an anchored tile grid. I'm not going to call it ATG, but we know that it needs to be anchored because we're going to use anchor position inside of here. And okay, so let's say I'll just say point 0 is, I'm just going to do 0 with no underscore. 0 we're going to say is our current location, which is the tile grid anchored position. Random direction as long as it's not further away from the destination or outside the rectangle, yeah. I mean, it might be kind of fun to have it wander off the side too sometimes. Ghosts are not constrained to the board. Okay, so point 1 is our current position. Point 0 and point 1 I'm going to use, so let me correct my prior statement to say point 0 is the current position, point 1 is the new position. The distance between them is, we actually have math.dist, booyah, recently added. I might need to update my CircuitPython, I'm not sure. Math.dist, and that takes 2 tuples, which we already have, so point 0, point 1. So now we have the distance between our points, so that's D. Distance ratio is, right, so dt, how big of a step do we want to take? And our units are pixels, so 1 pixel is pretty small. Let's say we want to step by maybe like 3 or 4 pixels each time. I'll start with 4, we'll see what it looks like. So 4 over distance is the distance ratio, which they call t, but I'm going to call distance ratio because it conveys more information. So now the point, so new point, or next point equals this stuff. So we need to go back and fix all of these. So we're going to call this next point. So 1 minus t, t is distance ratio, which this is very unhappy about, so I will copy paste it. It doesn't want to just multiply this without like a sign, I think. And it's also mad about a lot of other things too. Okay. Actually don't, I mean, I guess maybe it's because of the missing variables. So x0, that is, we're calling that point 0.00. tx1? tx1? Is that t times x1? I guess that must be t times x1. Sometimes I wish math equations were more explicit. So t is distance ratio times x1 is our 0.1 x, which is the 0.10, because that's a tuple. So this says the point xtyt. Is that this? It's not the same as this t, though. It's a different t. Because this t is the ratio. But I'm kind of confused, like, how is this ever going to be... How is this ever going to be changing? Well, okay, it's going to be changing because the distance is going to be changing because the next time we do this, our start point is different. Yeah, okay. Okay, so t, again, distance ratio... I still don't really understand what the problem with that is, but let's not worry about it. Y0, that's 0.0 y, which is 1 in the tuple. And then, yeah, this is another ty1, so t is distance ratio and multiply by y1, which is 0.11. Okay, and then what is the actual problem with these? I'm not... Unexpected expression syntax? Why is it unexpected? Do I have wrong parentheses? I probably have wrong parentheses, no? Okay, so my outer thing is parentheses, and those match up. So I have a tuple, and my tuple has a comma here, separating the two items that are in the tuple. And each item within the tuple has parentheses around it. And then the first thing in there has parentheses around it, and it's 1 minus distance ratio. What? That is not the same thing. It just got rid of it. I don't want to remove the parentheses either, because then that's going to get multiplied before that's going to get minused. Like, we need the parentheses. And this is even not just removing the parentheses, but removing the whole variable. Is this not spelled right? It is spelled right. What's wrong with 1 minus a variable? There's no problem with that. Var equals 1 minus distance ratio? I am at a complete loss on that. Now use var exclamation. It seems to be the destination point. 1 minus t will reach 0 when t is 1. Very confused. Is this messed up because of these? No. Use your variable? Use what variable? I don't know what you mean. ID will be happy? Oh, use var instead of this? I mean, I guess we could do that. I really don't like that, though. Why is it doing that, though? Is it a float problem? But I mean, it would be the same problem with this. Okay. I'll use the variable. I don't... Let the record show I'm not very happy about it, though, because I don't understand that. 1 minus distance ratio. I don't understand at all what the core of that problem is. I think we will need ints somewhere probably, right? Because we're going to end up with like... I'm pretty sure we're going to end up with floats. Let's just call slide the planchette to... I'm just going to pass something kind of random. Function takes 2 positional arguments. This needs to be a tuple. Okay, I do need to update this. Really want... I don't remember when it was added, if it's in one branch or not, but I'm just going to go to the beta. That is so weird. That's going to be like that thing, that weird, that's going to live in my head for a little while today. I don't understand that problem at all. My brain doesn't like to have problems that are that perplexing. Module has no dist. Beta 0? Is it not in the beta yet? I thought there was just a release, though. Math.dist. I mean, there is, like, you have to have something enabled in order to get it. I guess maybe this board doesn't have that thing enabled, whatever it is. I forgot exactly what it's called, like extension math something. I don't know what it's called off the top of my head. I guess this one doesn't have it. I don't know. Guess we can write the Python version. I'm going to call these ones point A and point B so that we're not repeating those variables. I don't think that's right. Is it? I thought we needed square root. Can you get the distance between 2 points without the square root? No, I don't think that's right. Okay, so they're saying x2 minus x1, so that's going to be point B x minus point A x. And that's going to be point B y and point A y. Yeah. Either Pythagoras or trig. Yeah, that's what. And this one's Pythagoras. That's what I was thinking. I think that other one, the Copilot. I don't think it's technically Copilot, but I'm going to call it Copilot for the ease of talking about it. My apologies to GitHub or whoever owns it. They're probably mad at me, but whatever. The autocomplete. I'll just call them all autocomplete. How about the autocomplete? I think was just, I don't know what it was doing. It's doing absolutely different. It was like taking the distance of the points between each other and then adding them together. It's not the distance really, but it's cool. All right, does that? Okay, let's turn this part off because that's just printing more stuff, which is making it hard to tell what happened. Because really we want to see the output from that print that I added to this. Oh yeah, we definitely want those to be ints. I guess we could round instead. I'm going to print the current point, which is 0.0. So we can see how far away from it is. Okay. Well, okay, I was imagining that it was still in the center of the screen, and that's not the case. It's actually hovered on the B, I think, right? Yeah. It's hovered on the B. Let me slide it to a different place. Let's say we wanted to slide it up from the B. That's really what I was trying to do. So the X is 63. I'm just going to do 63 and then something less than that. Although it does look like it probably worked, but it will be easier to tell if we only move in one axis. Yeah, there we go. So yeah. So our distance is 4. We took a step of up by 4 pixels, which is actually down in the value of y, but up the screen. That sounds right. So we would want to basically we need to loop some part of this. We could, well, I mean, one thing that's kind of tempting is move to the next point and then call slide again with the original target location. And so it would recurse on itself. But I do think CircuitPython doesn't like recursing too far, so I'm inclined to try to think of an iterative solution instead. All right, the kind of like lowest hanging fruit way to do this, I think, is just make the while loop here. While distance ratio, well, 0, so we'll just do all of this. While 0 is less than distance ratio is less than 1, then we're basically just going to do all of this again. I'll make delay 0.1. That's going to be a time.sleep. We want to put it at the... We could just put 1 here, I guess. Okay, so this time, well, we need to move it. So we have our next point. So let's go tile grid, anchor point, anchor position, actually. Equals next point, th. Okay, so move it to the next point, then sleep for the delay, and then while the distance ratio is inside the range, we just go and do all of this again. And point 0 is the anchored position, which has been updated here, so that's now the new point. We could just put next point here, but it's kind of 6 of one, half dozen of the other. It's the same way either way, I think. The position, that's like, let me rename that, in fact, to the target position. I'm going to actually go with location instead of position. Target lock. And let's do the full word, target location. Target location. Target location stays the same each time. We don't necessarily need to do that, but I'm just going to leave it. We recalculate the new distance. We recalculate the new distance ratio. We are going to end up, we need to move our next step. So one thing I guess we could do actually is, no, we need to update that before. Yeah, we need to update that before. So let's do this. I think we're going to like overshoot a little bit. Because on the last time through here, we're going to calculate distance ratio, and it's actually going to be outside this range. But because we only check this at the top of the iteration, we're going to have one where it's outside the range. We're going to calculate a point from it, and we're going to move to that point. Technically, it's going to be outside of the line. I guess we could do this again. It's kind of redundant. And then at the end, I think what we do is we set the anchored position to the target location so that if we're not quite there yet, which I think by doing this way, we're going to make it so we don't take the last step because it would overshoot, basically. So this is going to get us from wherever we ended to our actual target, which should only be a few pixels away by that time. Okay. before we see if it works, I gotta run to the restroom again, so BRB. Okay. Will it actually work? Oh. Yeah, that was pretty good. We can speed it up by changing the delay, and we can point it to somewhere more interesting. Let's start on the A and then slide it to the C so that we get a little bit of a distance. It's the best we can do with the letters we got for now. Or generate a square root table up to the size of the screen. A square root table up to the size of the screen. Not sure I follow. Square root table. Like basically make a lookup table that gets it so we don't need to do this or something? Guessing that's what you mean, but I'm not sure how we would. Well, it would just be. Oh, okay, I think I see what you're saying. So we would make a table that contains the answer to every possible one of these up to the size of the screen. I think I see what you're saying, yeah. To basically trade off memory to store that stuff and look it up versus the time of calculate it. I suspect this won't be that slow, honestly. I suspect this is actually fairly fast. There is a way with ULab. So Trig, you mentioned Trig is the other way to do this. There is a ULab way to do this, which might be faster. I haven't actually profiled it. But that does exist as well. I think this will be fast enough. Honestly, this delay here is probably what's making it as slow as it is. Let's move it from A to C though. So instead of putting this here, let's do it this way. Let's say, so we want to put it at locations, I'll just say locations A. Yeah, so let's put it at locations A, and then let's slide it to locations C. Locations C. And I'll leave it on the delay here. You know, one more thing we could do actually, step size equals 4. And then here we can say step size. So you could actually change that as well, which would help you get it to go faster or slower depending on your needs. Can you put a space in the string to recenter? I'm not sure if I follow exactly. Do you mean basically like we would have a space here as one of these things, and then when you came across that in the message, it would like go back to the center of the display, which in my case it's 480 by 320, so on this device that would be 240 by 160? Not sure if that's what you mean for sure or not. So then like in that case, if you were to come across a space here, okay, yeah. So then if you came across a space here, it would move you back to the center of the screen. We could, do we want space on the skull, or do we want, I could maybe even just pick one of the empty spots. maybe spaces on the skull. We can do it that way too. And yeah, totally, we can do that. We can totally do that. It might be, I might eventually do some of these that are a list as well. So I would also like, I'll just do all lowercase. I would also like, I think, hello to be here and to actually be a list of points. So the first point will be the H, and then it will actually kind of be like all of these ones here, which we could do with the slide, but I might, yeah, maybe we'll just do that with the slide, actually. So we would give it like the first point on the H, and then we would give it the last point on the O. I don't know what the pixels are off the top of my head, but it'd end up being something like that. And then our code is going to say, if it's a list, move it to the first one and then slide it to the next one and go all the way through the list. So you could actually do more than one if you wanted. That way, when it wants to say hello, it will like slide all the way across that for you, since it doesn't really fit in the window. I mean, we could just center it on there, you get the point, but it'll be nice to slide it across. Okay, is that going to slide between A and C correctly? Yeah. We do have the, problem. I don't know if it's a problem per se, but it does. We'll need to make sure when we're doing this that we pause a noticeable amount of time on the letter, because the way it moves from A to C is basically right through B. I mean, it's a little bit south, because of the curve, right? It's like not lined up perfectly, but it's close enough that conceivably a person might believe that there's actually a B in there, especially if we're doing something on hello where we're sliding across like that and they've seen it that way before. For individual letters, though, it's got to like pause on there. I thought the blue marker at the top was a bra, but the pointer was just half off the screen. Nice. Yeah, no, yeah, before it was up there. Hello, everyone. Hope you guys are having a lovely day. Yeah, thanks. You too. That's over on Twitch. The user That Onion says that for folks who don't see the Twitch chat. Thanks for joining us, my friend, over there. F and H would be a problem. Yeah, because yeah. So those ones aren't even curved, really. S, T, and U as well, pretty much, right? So let's play with the speed a bit. I think if we so we can just pass a delay here. I suspect something, like, even if we just go twice as fast, I bet that's like... Oh. Was that any faster? That felt slower. One Mississippi, two Mississippi, three Mississippi, 3.5-ish? Mississippi, two Mississippi, three Mississippi, 3.5-ish. That's about the same. Did I actually use delay inside of here? Yeah. Interesting. Huh. What if we just do 0? This is basically as fast as it can go, which is definitely fast enough to be kind of messed up. Okay. That one's definitely faster. But it even, it kind of gets to the point of being jittery. Which I will say, the camera here, the webcam, makes that jittery effect look worse than it does to the naked eye. just looking at the display, but it is still visible to the naked eye too. I'm surprised at the non-difference between these two. I mean, I guess it's just, well, really what that's telling us is that the sleep is not where most of the time is at. I guess, I mean, realistically, the display refresh is where most of the time is at, honestly, right? I wonder what would happen if we did this. Display.auto refresh false. And then display.refresh. We don't really need to turn this back on, honestly, but it seems like the right thing to do if we're going to turn it off inside the function. Does that make any difference, or? Not really. So then the other thing we do have is step size. I mean, step size 1 would be way too slow, I assume. But it would make it way more smooth, right? It's not going to look jittery at all with step size 1. Vision by 0. Distance was 0. Pretty sure that means we're done, right? Basically, what that means is that our last step was perfect. Well, which makes sense since we're only stepping by 1 pixel. Yeah. So that's, I guess that's it's not very likely to happen with step sizes that aren't 1, but it is probably for the better that we put that there. Maybe pre-calculate the list of points and then play to slide. Yeah, you could do that. Although honestly, I suspect the majority of the time is in the display refresh. Let's try. So if we put after right here, let's put it back to 4 for now. Let's turn off some of those prints. Okay. Let's turn those into milliseconds. How many nanoseconds are in a millisecond? Is that 1,000 or? That's not helpful. Oh. 1 million. Yeah. 1 million nanoseconds equals 1 millisecond, apparently. So let's divide that by 1 million to get 2 milliseconds. We're going to be with less than a millisecond, though. So then, yeah, I think the display, well, that's what this is going to prove out, though, I think, is that the display refresh really is where all the time is at. Okay, so time took after before. Let's put that in parens and then just divide it by 1 million, which is going to be a fraction of milliseconds, or a decimal, I should say. So not even 1 millisecond. But if we take before, so we know that all of this part takes that less than 1 millisecond. If we just do this part now, we can see how long it takes to set the anchored position and refresh the display. I suspect will be much higher. Yeah, 119 milliseconds, so several orders of magnitude. 100 times, over 100 times as long. I mean, still relatively quick, right? 1/10 of a second is not slow by any means, but no. All right, we get to play the weekly game of where's the ban button, because I'm still failing to remember where the ban button is. There we go. Okay. And then how to close this. Okay, there we go. Nice. Let me catch up on the chat also. Maybe, so I'm impressed. Check on the longer distance. It will be easier to see the speed difference. Yeah, that's true. Let's put in Z. And then I probably got to head out after this. Going to a craft fair here in a bit. Although my wife's not back yet, but I suspect she'll be ready to go when she gets back, because it's right down the road and they close in another hour or two. Let's find Z. Z. Kind of likes calling it Z, but I'm not used to doing so. 405, 194-ish. I'll get rid of this one for now. I mean, there's no harm in keeping it, actually. We might as well just keep it. What did I say? 405 what? 164, maybe? 194. So let's slide from A to Z then instead. Or actually, we should be able to... we should be able to do this, actually. We should be able to loop through the message again. So instead of this, let's basically say... turn both of those back on. Eventually, we might raise the time on this sleep, because that's how long it's going to spend parked on the letter. But I'll leave it for now. And then, so instead of just setting the anchor position, what we're going to do is slide it, the planchette, to this. Division by 0. What? Oh, why would the distance be 0? Okay, so we were on A, we went to space, which was in the center, so the space was kind of like on the snake, basically. We're going to B now, then we're going to go to C, and then we're going to go down to Z. So I don't really know what that distance 0 one was, but by ignoring it, we basically did the right thing, so. And yeah, it is very slow. We didn't do a delay here. So it's on 0.1, but as we saw before, well, that's actually probably double. I mean, that is about doubling how long it would take. I feel like this 0.2 looked pretty good. Yeah, I think that's a much more reasonable speed. All right, while that's running, I will start to bid you farewell. So thanks, everybody. So you want to talk to ghosts in the machine. Yep, that's the idea pretty much. 120 milliseconds was the time. I was told it takes a user to process that a button did not respond and then think to click again. Yeah, users are pretty fast at knowing when a thing didn't work yet. I will say that. And how's it going, Tyeth, as well? Nice to see you over on the Twitch chat. All right, I am going to head out for now. Going to the art fair down the road. Should be fun. I'm excited. Thank you to everybody for watching. I will be back definitely next week. Possibly I'll pop on Monday in order to work on this project some more, but we're getting pretty close here, right? Like the main things left to do are the Adafruit IO integration and then make the planchette look better. And that's basically what's left, and then this is actually pretty much functional. And then maybe resize it for the smaller size, I think I want to do as well. So, yep, thank you to everyone for watching. I will catch you later again next week. I'll be back for sure, possibly Monday. You can follow, subscribe, or whatever if you want the notifications for that.